Is it coming now?
Yes, it is coming.
Okay. Yeah. Okay. Can someone check if audio is good on the YouTube? Oh, Kripa is also there. Very good.
Hello, Sukanya. Can you hear us?
Audio off.
Yeah,
Hello.
Oh, hello,
audio
hello.
is working, I think.
Okay, good. Then I request everybody to mute and maybe we can start. Shikha?
Okay, sure. Just give me a second and I'll share my slides. So let's first we welcome everyone to this Pavinari lecture. It's a series which was earlier started before the IQUIP conference by Shubhavati and Vandana, and we are reviving this series. And today's lecture by Professor Tanushri Saha Dasgupta will be the seventh lecture in the series. We welcome everyone. And before we start, we'll just introduce a little bit. I will give a little introduction on GIPWG and our some major activities under GIPWG. And then we will request also Professor Shubhavati to say some things about the IPA, Indian Physics Association, under which the GIPWG comes. So let me just share the slides. So can you see the slides?
Yes.
It's not coming on YouTube yet.
Yes, Shikha, we can see.
Okay.
You can
So
see
this
this.
is the link. So Gender in Physics group is under Indian Physics Association, and this is the website. So IPA was formally formalized by GIPWG in May of 2017 with the mandate of coordinating national efforts towards gender parity in Indian physics profession. It focuses on addressing the challenges faced by women, fostering environment of equal opportunity and recognition for all individuals. And at present, we have some groups, one for high energy physics, condensed matter physics, and nuclear and astrophysics are some subgroups. And also, there are various other gender groups on astronomy, general theory of gravitation, etc. And for all these panels and groups, main focus is on subject specific issues and provide wider reach for sensitizing the community. And all these groups together, all these women in physics groups basically organize conferences, workshops, panel discussions, as well as many special sessions in physics conferences for raising awareness about gender related issues for women in science. These are some major activities, and Pressing the Progress was a milestone conference in 2019 in India, in Hyderabad University. And it came out with a Hyderabad charter, and it is sort of a guiding principle for achieving gender equity in many domains. And and we strive for many achieving many of these goals. Then there was this IQUIP conference in 2023 with a very large participation, and again organized by TFR, Homi Baba Science Center, IPA, and GIPWG. And this was another workshop which was carried out by Rohini. We are also remembering Rohini while we are doing this, reviving our Pavinari series. She has been always a torchbearer and uh, sort of role model for many women activities in India. As we start these Pavinari series, basically by Professor Saha Gupta or Purnima Sinha, here are some earlier Pavinari talks by various scientists. I just like to mention briefly that we have a survey by GIPWG which is ongoing, to assess the representation of women faculty in universities and institutes and attempt to comprehend the nuanced challenges faced by them. This survey is still going on. We have about 500 responses, and maybe after this Pavinari talk, I'll once again circulate mail to you. Please forward it to as many scientists as possible, women scientists especially. And basically, by spearheading these activities, initiatives, GIPWG aims precisely to derive positive change and foster more inclusive and equitable environment where women researchers are able to freely communicate with each other about their problems and challenges. So, thank you. And with this, I will request Professor Shubhavati to please give her presentation. Say a few words about Indian Physics Association.
You are muted. Subhavati, you are muted. Subhavati is muted.
Yeah. Sorry, actually, I had to change, so I was trying to request Gondwana. Yeah. So, first of all, I would like to congratulate Shikha and the GIPWG members for restarting this series. We started this series in 2022, as she mentioned, and it's good to see it is happening again. Now, I want to say a few words about IPA because GIPWG was formed under the Indian Physics Association. And Indian Physics Association was founded in 1970 with the objective to help in the advancement and dissemination in the knowledge of physics. At present, we have about 4,700 members and 48 chapters distributed all over India. And GIPWG is liaising with many international organizations like the APS, IOP, and AAPPS, Italian Physical Society, etc. And we are trying to strengthen these links and we are trying to organize some joint activities if possible. And also, if the members of IPA can get some advantages in the conferences which are organized by these bodies with which IPA has a MOU. So these are the interesting things that which all the time we may not know. And so this is what I wanted to mention. And also IPA activities include publication of physics news, its bulletin, which is published quarterly. And IPA also organizes special lecture and seminar like the DAE CB Raman lecture series, PA Pandya lecture series, IOP, IPA, Homi Baba, Cockcroft Walton lecture series. And in this series this year, Rup Manjuri Ghosh, who is present here, she will be going to London to give a series of lectures, and the topic is actually aligned to the quantum science. That's what the topic they wanted this year. So Rup Manjuri will be going. We are also organizing young physicist meet for young researchers, and there are theme meetings and there are various award categories. And so this is about the awards. I said there are many awards, like some are like R.D. Birla Memorial Award. Then there are some award for specifically for women scientists, best thesis award, then Olympiad awards, etc. And then these are the lecture series I already mentioned about. This is the special latest executive committee. And I wanted to also share good news with people presented here and in YouTube that today the World Academy of Science Fellowship results were declared, and IPA past president Dr. Ajit Mohanty and also Dr. Subhathi Rao, who is a life member of IPA and involved with the GIPWG activities and is in the advisory committee of GIPWG, was selected as TWAS fellow this year from India in physics. There were 2 people selected in physics. So that is really very great. And I wanted to share this news and congratulate them on behalf of IPA. And Gender in Physics Working Group, you already heard about Shikha. And I would like to end with an appeal for, membership of IPA. So I would like to request everyone, if in your institute and all the physicists you can enhance the membership of IPA, because we really do not have any other source of funding other than the membership. So we are really trying to enhance the membership for that reason, as well as for having a physics community with a greater reach, and it can involve and having a network with the physicists, researchers, even students, and also in the other professional networks. So with this appeal, I would like to finish this, and then Shikha, you can please take over.
Thank you, Shubhavati, for your introduction. So let me just introduce Professor Saha Gupta before her lecture. So Professor Saha Dasgupta works in the area of computational condensed matter, material science, and a major thrust of her research is the application of first principle electronic structure calculations to understand the physics and chemistry of novel and complex materials. She obtained her PhD from Calcutta University in 1995. She was a postdoc fellow at Onera, Paris, CNRS, Sergi Pontais, France, Max Planck Institute, Stuttgart, Germany, and ISC Bangalore. Um, Professor Saha Dasgupta joined S.N.Bose National Center as lecturer in 2000, and she is currently a senior professor and also director in the same institute. She has so far produced nearly 20 PhD students and published more than 300 research papers. She is a fellow of American Physical Society, the World Academy of Sciences, Indian National Academy of Sciences, Indian Academy of Sciences, National Academy of Sciences, India, and West Bengal Academy of Sciences. She is recipient of Swarn Jayanti Fellowship, MRSI, ICSC Superconductivity, and AM, Material Science Annual Prize, D.A. Rajaramanna Prize, P. Shield Memorial Award, APJ Kalam Award, HPC Award, and J.C. Bose Fellowship. She headed the Max Planck India Partner Group, Advanced Material Research Unit, and Thematic Unit of Excellence on Computational Material Science at S.N.Bose Center. So now I request Professor Saha Dasgupta to please give her PAVINARI talk.
Thank you so much, Shikha, and it's really my privilege to give this talk. I'm grateful that you have thought about me for giving this talk. And in fact, the title, I think Shikha has some credit in even designing the title. I don't know whether I will be able to do justice to the title, but I will try to do my best. So let me share the screen. I hope the screen is visible.
Yes, it is visible, but
I
it is
just
not full screen yet.
Is it full screen now?
Yes, now it is fine.
Okay, so the title as announced, it's the legacy of Bose, Purnima Sinha, and rise of women in quantum science in India. It's a long title, as you can see, and I think it has basically 3 topics, and on each of the topic, one can give an 1-hour talk. So that's why I said I don't know whether I'll be able to really do any justice. But what I will try to do is to give you a glimpse of this topic, and I will also try to, indicate some of the references which has been devoted to each of this topic. So as has been already mentioned, I come from S.N.Bose National Center, the institute which has been instituted by Department of Science and Technology to honor the life and work of Professor S.N.Bose. So S.N.Bose, I think is a forgotten genius who laid the foundation of quantum revolution. I very consciously use the word forgotten because I was recently served as a jury in some competition, which were like high school student. and it was organized by BITM, the Birla Museum here in Kolkata. And these students were actually giving us the history of quantum science. And nowhere in none of the presentation I could actually see the name of S.N.Bose. So, and this competition is happening in India. So I asked all of them, have you not ever heard the name of S.N.Bose? So they were actually very, very hesitant, but finally they say that they know all the names, like they know Schrodinger, they know Dirac, they know, every name that were connected to quantum. They could say all of these, but not S.N.Bose. So I think these kind of talks should be organized more and more as much as possible. And what I would request, these talks should actually in the audience have more and more of the young people. Those who are old like us, who already know some bit of history, for us, it has of some value, but I think it will do much more if we can bring it to this time. The time was very short. I was really trying to reach the colleges of Kolkata, but the time was not enough to do that. But I think we should, this will be actually a request to the organizer. Next time you organize such a talk, please take it to the young people. Well, as you all know, 1924, Bose authored the last of the 4 revolutionary publications, the other 3 being that of the Planck in 1900, Einstein in 1905, and Niels Bohr in 1913. And that led to the new foundation of quantum mechanics, which in textbook are known as Bose-Einstein statistics. But I don't know whether we should really call it Bose-Einstein statistics, because the statistics really came from Bose. Einstein followed it up, showed its application, but I think the statistics should have been called Bose statistics. Anyway, as stated by Einstein, the method used here gives quantum theory of an ideal gas, as I will work out elsewhere. Bose, as you know, didn't get the Nobel Prize, although he was nominated quite a few times. But half of the fundamental particles in this universe are named after him. I think that is much more than winning a Nobel Prize. And they are named after him. Several Nobel Prizes are awarded for the work related to this very particular word, namely the bosons, starting with the BCS theory of superconductivity in 1972, ceramic superconductors, which are these high TC superconductors, in 1987, then superfluidity in 1996, laser cooling, 1997, Bose-Einstein condensation in 2001, superfluidity in 2003, Higgs boson in 2013. That's the latest one. And among all of them, at least 2 of them, even the name holds the key name, namely the boson. So I think this is much more than just winning a Nobel Prize. I don't know how many of you know that Bose spent 25 long years in Dhaka, and those were perhaps the best years of his life. I don't know, a modern trend, at least in India, has been those who are teaching, they are teachers, and those who are doing research, they are researchers. And there is a separation, and there is kind of a caste system that if you are a good researcher, you are not a teacher. If you are a teacher, there is no good research. But I think we have forgotten our history, that being a good teacher is possibly very important to be a good researcher, which in Indian system somehow has been ignored. So he not only nurtured the physics department. I had the opportunity of visiting this place in Dhaka University, the Karjan Hall, which is have a great architecture. As you can see, it's from the British time. So he really built up the physics department there by designing the curriculum building labs. He was a theoretician. In spite of that, we are always in these narrow domains of theory, experiment, these days, even with the calculation. But there is no such narrow thing, at least was in his mind. So he, in spite of, he started because his master's degree actually is not in physics, it's in mixed mathematics. That time it is used to be called mixed mathematics, not applied mathematics. So he started his career as a mathematician, but then got into something which had huge implication in physics, in theoretical physics. But then he changed his course of action and he got into experiment. So a person, when a scientist is not really bounded by the boundaries, which unfortunately in current time we have forgotten about. So he built up even the library, but this is the time he also did his groundbreaking work, which today you know, this Bose-Einstein statistics. So in Dhaka University, while building this physics department from scratch, among many other subjects, he started teaching thermodynamics and Maxwell's electromagnetic theory. And when teaching this, he was very uncomfortable teaching Planck's radiation theory. So that's basically the spectrum that you can get out of a black body radiation. All of you know this. So this is this part, which is basically the low wavelength part. You can describe with the Rayleigh-Jeans law, while the high wavelength part is with the Wind's displacement law. So there was no consistent theory really. And Planck, which he calls it's an act of desperation, he really gave an expression which is seen like this, where he assumed that really this radiation is coming in form of a quantized form. And having such an idea of something which is not continuous but quantum was already extremely radical and without having really proper kind of justification. So he said it's my act of desperation. So with this idea of quantized form, he got, you can see that there are two factors. He got the first factor, the second factor, and the first factor is basically like a classical phase space idea. But this is the formula with which he can fit the entire spectrum. But Bose was actually very, very dissatisfied because he said if this formulation has a kind of quantum nature where you are thinking of this quantized, the form of the radiation, why the first part have to rely on some kind of a classical theory. And he discussed all this thing with his friend Meghnad Saha, who had his birthday only few days back. And this is actually the writing from Meghnad Saha. So which says when the author of this note was studying this paper together with S.N.Bose, the latter, meaning the S.N.Bose, was led to a very ingenious deduction of Planck's law of radiation. He showed that the number of cells A in a phase space can be determined by this following equation, where this integration basically extends over the whole phase space covered by particles. What are these particles? These particles are the number of quanta available. So what is his greatness? That in order to fill all the cells in this phase space, these particles, which are the photons, they have to be indistinguishable. So I think the biggest contribution of S.N.Bose was to do this counting properly. So therefore, the Bose introduced a new method of counting in order to arrive at Planck's formula. And this method of counting is what is known as Bose-Einstein statistics. And therefore, I think it should be called really as a Bose statistics. And then the genius of Einstein was reflected because he immediately appreciated it and he understood that this can be actually applied to the ideal gas problem. Well, here I show again the Rayleigh-Jeans, the classical one, and the quantum full Planck's formula, and which basically at the low frequency part at the low temperature, they actually kind of match with each other. But then it gives rise to, all of you know, this kind of tree distribution. And in contrast to the fermions, if you have a cold fermion, that will give rise to a Fermi sea. On the other hand, if you really cool down the boson, that will give rise to a Bose-Einstein condensate. So Bose had this derivation. Then he wrote paper. The title of the paper was Planck's Law and Light Quanta Hypothesis, and sent it to Philosophical Magazine. The paper got rejected. Many of us should learn from it. If your paper gets rejected, that doesn't mean really your work is bad. I mean, this is probably a message to many of the younger people, not a senior people like us, for who have gone through all this rejection all the time in our life. But then he sent it to Einstein with a covering letter, and I, basically show the covering letter here. And you will see in the covering letter itself, he gives the essence that I have tried to deduce this coefficient in the Planck's law, independent of the classical electrodynamics, only assuming that the ultimate elementary regions in the phase space have the content HQ. So that is basically the essence of his finding, which he already has put in the covering letter. And I think he was very modest. He said, I don't know sufficient German to translate the paper, but together with Meghnad Saha, he actually has translated from German to English the paper on general theory of relativity of Einstein. So I think it is his modesty. But then he says, if you think the paper is of any worth, I'll be grateful if you arrange the publication in Zeitschrift for Physics. And that was written in June 1924, as you can see. And Einstein's reply came pretty fast, within a couple of weeks. He translated the paper in German as requested by Bose and published it in Zeitschrift for Physics. As you can see, his reply actually was written in German. So, and he not only sent it for publication, but put this note, which I have already said about. In my opinion, Bose's derivation signifies an important advance. The method used here gives quantum theory of an ideal gas, as I will work out elsewhere. So it's a really, really strong note coming from Einstein, together with this paper that was sent to the journal. And I just take this opportunity. So we have Bose archive at S.N.Bose Center, and I welcome all of you to have a visit. We even now have a virtual tour. So if you cannot make it to come here physically, our institute website has a link to this virtual tour. You can even take advantage of it. And many of the letters that are shown in my talk are actually taken from this archive, because the archive has all these original letters. Well, so last year, since the paper was written in 1924, last year was the centenary of this Bose statistics, and we celebrated it in a big way by organizing 3 international conferences and several different outreach. And many of this outreach was in collaboration with IPA. So I must thank IPA, and also with Bongyo Bigyan Parishad, which is the organization that was instituted by none other than S.N.Bose. So according to Lev Landau's, he had the logarithmic scale of productivity and genius. So it's a logarithmic scale. In this scale, Einstein was ranked 0.5, and Bose was awarded a rank of 1, along with Niels Bohr, Heisenberg, Dirac, and Schrödinger. So that already tells in which class he belonged according to Landau. And this, I think, is an anecdote from Jahid Hassan, who in the last, from Princeton, so his family is from Dhaka. So among the educated society in Dhaka that time, they said there is this young professor, and no one knows what he is calculating and what he is all the time doing. But he was looked upon as someone which no one could understand except Einstein. So that was the kind of perception in Dhaka that time. So besides his scientific attributes, Bose had a very progressive mind compared to his time. I put the word compared to his time because if I compare him with Raman, Raman had a very, very different character. As many of you know, it is being documented now. He was very much against the women doing science. He created a lot of problem with the admission of the female researchers when he was the director in IISc, and really created an adverse situation. Compared to that, Bose was a completely different man. So this again is taken from the archive at our institute. This is the picture of Bose with his student. And I can spot actually 3 women. I don't know, maybe Shukanna or someone can tell me. I, of course, can see where is really Purnima Sinha. That time it was S.N.Bose.
I can,
don't.
yeah, there is another woman. Her name is Leela.
Okay.
Yeah, the
Maybe.
person on the other side of Bose.
Yes.
If you look at the photo from
Yes.
your side,
Yes.
to the right is my mother, Purnima
Yes, that
Sinha.
I can identify.
And to the left is Leela. I think her name is probably Leela.
And is this also a girl student? It looked to me, but I'm not very sure. But as you can
Yeah,
see,
I don't know. Sukanya would perhaps.
I don't think so, because first of all, the women at that time were all wearing saris. So I don't think, I think this is just a confusion. I think I'm not very sure of this Leela, whether she definitely did not complete her PhD, but I think she started research with him. That's as far as I know. I mean, I don't know the details further down her career. Yeah.
yeah, but it's interesting. You can see that even at that time when a picture is taken, I found that it is kind of, it's not definitely completely balanced, but still you see that what we are trying to look for. You know, you have some 11 men and 2 women. I mean, that is at least, even if you think of all the Indian institute, you know, your GIPW is trying to get all the statistics, maybe that will be the statistics. So, well, that brings me to Purnima Sinha. I'll be very brief because I think both Shukanna and Shuparna, they are there and they can say much more than what I can say. So she was a promising physics student at Calcutta University, joined her PhD program in Professor Bose's group, and she was the only woman in this group it is written, but now I see from this picture there were 2, but maybe since the other one didn't continue for fulfilling the PhD, maybe that is the mistake of writing only woman. Sophisticated instruments were built, and I will try to show some of these from with Bose's active guidance. So that is what I'm saying. A mathematician turned into a theoretical physicist, turned into an experimentalist. You know, if something needs to be done, he will do it. So Bose, he took a study leave from Dhaka University. He was reader in Dhaka University and he traveled to Europe. So his entire idea was to do work with Madame Curie. But Madame Curie, being Madame Curie, told him in the first meeting that to work with me, you have to learn French. And Bose, again, I think Bose was a very modest man and a very humble man. So he could not even tell her that I already know French. So he quietly accepted it and he started working with Maurice de Broglie, and there he got into crystallography and he got back to Dhaka and continued with his passion with the crystallography. So Purnima Sinha's PhD work, that's the cover page of the thesis from Purnima Sinha, which I think both Shukanna and Suparna you know very well. It was in analyzing the structure of clay, which is, I think, very complex. And clay was collected from all over different places of India and was analyzed. And she was awarded the PhD degree in 1956, the first Indian woman to earn a PhD degree in physics from an Indian university, at least definitely from Calcutta University. The statement that from an Indian university, I don't know how rigorous it is, but definitely from Calcutta University. So this is the picture of Purnima Sinha. Many of you must have seen before. And this is the picture of her with Dirac and S.N.Bose. And as I said, I will show you, some of the X-ray equipments. So this one is in the Science College, and this possibly is from Dhaka University. But the Science College, many of these instruments were actually made from the Second World War. There were some scraps being sold in various parts of Calcutta. So those were collected and the instrument was built. I consider these amazing. So we have really been out of all this excellent skill we had. If we think of S.N.Bose, we think of S.N.Bose, all of them built their own instrument. For whatever reason, we are completely out of it. Think of doing computation. Most of the people work with some packages. For the instrument, these are just turnkey instrument. I don't know why we have lost all this great, kind of expertise and talent and the knack we had. Even a mathematician can make an instrument if that passion is there. I think what we are lacking is possibly the passion. This is again taken from her thesis, and there are several such that different places where the samples were collected, and these are some of the spectrum. And I was very, very fascinated by the fact I found several of her publications appeared in Nature. So these days, how many Nature publications from India happens? I looked at her thesis and I found this was, of course, done when she has already gone from, Science College. She was in US, I think. But I think still the affiliation was shown as Science College, Rajavajar Science College. And before there were several of the publications which were in Nature. So I think we actually reached some height, and that was done with such kind of instruments. So that is why in some way it pains me. And after that, she moved to biophysics, and that is where she moved to Stanford and started working with the theoretical biologists and studying basically the structures of bases and clay. And upon her research, upon her return, she worked in the Geological Survey of India and the S.N.Bose Institute for 2 decades before joining the Central Glass and Ceramic Research Institute. And in CGCRI, she worked on physics of ceramic color. And Purnima Sinha is probably one example, very concrete example, because she was direct student of S.N.Bose. But S.N.Bose also had great collaboration with Ashima Chatterjee. I don't know how many of you know about it, that Ashima Chatterjee worked on the medical plants extract, and again, using some small molecule spectroscopy, all this work started with S.N.Bose. So all I want to say that whenever S.N.Bose wanted to get into some scientific interaction or collaboration, gender was never an issue, which I think we are trying to press for it, but for him it came naturally, and I don't think he ever bothered about it. In this context, I'm tempted to, even share an anecdote which Purnima, which I'm sorry, maybe this anecdote will come back to me and I will share towards the end. So it has come back to me. So it's actually an anecdote from Chandrima Saha, because I think her parents and S.N.Bose, they were great family friends. So apparently S.N.Bose one day visited their house, and Chandrima was supposed to take him to meet Vishnu De, the great poet. And Chandrima came with wearing a trouser. I don't know how many of you know that she used to play cricket, and she was a very, very competent cricketer. So, and she is little boyish, so she came with trouser, and her mother objected to that you are going to a great personality and you are accompanying another great personality. So as I think Shukanna was saying, those days the women had to wear saris. So her mother objected, but S.N.Bose, comment was really remarkable, saying that she should wear what she is comfortable with. I see no problem wearing a trouser. So that there are several such instances which actually tells that he was probably way ahead of his time in terms of not having such kind of any bias in terms of gender. So now coming back to we are almost towards the last topic. So this year is the International Year of Quantum Science and Technology, and very recently announced Nobel Prize has also gone in this domain. There is no wonder about that. And we had the first quantum revolution with all this laser and semiconductor, and now we are at the verge of second quantum revolution, where all this quantum entanglement and all of these are being used in a different form in terms of the quantum sensing, quantum communication, and etc. So I think the whole world is somehow into some kind of race into join into this second quantum revolution. And India is not lagging behind, in the sense there is this national quantum mission been announced, and we had the announcement from our finance minister, and it took 3 years to materialize, but I mean the NQM is finally in place, and I think the money has been distributed to some extent in these 4 verticals. So this brings us to the kind of the final topic of this very big title, that since for S.N.Bose, it didn't matter really whether it's a man or a woman, and he really encouraged all the women to get into science. So what is the status of India's women in terms of the quantum research, which was S.N.Bose's passion? So this was one of the conference I just mentioned. We had a year-long celebration of Bose statistics. And this was one of these 3 conferences, which the conference we focused on women in quantum science. And this is the group photo that was taken. And you can see that the number of, we tried to reach as many as possible. Of course, we were not successful to getting into everyone, but still the group is not small at all. So we had some role model speaker, and you can see Rup Monjari here, who is in the audience. And there are people who, I want to say that this was an international conference, so we had international speaker. But those here who are even here as an international, they were born and brought up in India. So there are Indian women in quantum science who are now settled abroad, and they are being recognized worldwide. So I just want to make that point. So you can see Shukanna here. She gave a fantastic talk, much more elaborate on life and work of Purnima Sinha than what I could cover in this very limited time. We had Shamima Chaudhary because from Dhaka, and she spoke about S.N.Bose and the University of Dhaka. Sumati Rao, we have just mentioned, she spoke about the history of this working group of women, and we also have representation from Department of Science and Technology. There was a galaxy of these women speakers. So all I want to impress on you that there is no dearth of this women workforce in terms of working in this domain of quantum and making this second quantum revolution and India's contribution in it a successful one. We had 2 panel discussion, and you can see our organizer Shikha sitting here, and where we discussed about the opportunities for women with a focus on quantum science and technologies. And I think that was actually the last public appearance of Rohini, and she was very sick, so she could not make it. But even in spite of the fact that she was sick, I think her speech, very small speech, but that was a very, very spirited one. So it started with at the centenary celebration of S.N.Bose. I have spoken about the structure of light, and she really got very, very motivated and carried away. And maybe because she was not well. And we still have that recording of her speech. So if anyone wants to do anything with that recorded thing, you are most welcome. So that's the conclusion we had, that today we are here to acknowledge these challenges and most importantly, to take collective action to overcome them. I have probably few minutes left. So in my own way, I will try to tell or at least highlight some of the work of some of the Indian women quantum scientists. And this in no way is an exhaustive work. It's just to give you some glimpse and just to tell you that good work are being done by the Indian researchers in the domain of quantum. So Kasturi Saha, who is in IIT Bombay, she is working on quantum sensing, especially using the diamond NV centers. So these NV centers in diamonds are atomic defects with a long spin coherence and high magnetic field sensitivity. So therefore, they can be used for nanoscale sensing and noise measurement. And she has set up a very nice lab, and she is even chosen as the head of the hub on quantum sensing. The other example is Urvashi Sinha from RRI, Raman Research Institute, where she has a very nice lab on quantum communication and quantum key distribution in free space, fiber, and integrated photonics she has been using, and she is really pushing it to be in the world level. Aditi Sende, who was also present in our conference, she is into the mathematical formulation of the quantum information using the knowledge of many body physics, the quantum spin system, and quantum information with the ultra cold gases. And Rupmanjari Ghosh, I think she is in the audience. So I'm no one to really, but I'm just trying to touch upon it. She is an expert on quantum optics. Her work with Mendel on 2-photon interference, I think, which was done many years back, but perhaps is the first one where creation of a source of entangled photon pairs and use of single photons was being used. So finally, I will like to end with my own work. So I work on quantum materials for quantum sensing using computational approach. And what we are interested in is in the strongly correlated electron system. So the strongly correlated electron system is like a quantum traffic jam. So that's a traffic jam, which we all know. But suppose instead of these cars, we really have these electrons, which are interacting, strongly interacting with each other. And therefore, they are correlating because it is not a 2-body problem, 3-body problem, but it becomes a many-body problem because each of these electrons are basically interacting with another one. And because of this strong correlation, several different novel phenomena actually shows up. And what is interesting, because of this strong correlation, they show extreme sensitivity to any small changes, like a change in strain or little change in temperature, little change in pressure, that can change the property very drastically. So they can be used as the quantum sensor, future quantum sensor. Like all our focus at the moment is on diamond envy center, but many of these, like these oxide interfaces or van der Waals heterostructures, here actually this strong correlation is in action, and that can be a fantastic way to use them as quantum sensors. And I use, since I'm a computational person, I use first principles modeling in terms of looking at its electronic structure. I also do machine learning in discovery of these new quantum materials. And the novelty of my approach is I not only use models, because to deal with such a strong correlation, you need to use some model description, but I try to connect between the material aspect and such model kind of description. So the issues for deliberation is generation of new strongly correlated electron system, search for novel phases, new phenomena, elucidation of basic mechanism, because in many of the cases, even the mechanism that gives rise to this novel phenomena is not really understood, and it's a kind of challenge. And if that can be understood, then that can be used really in terms of its optimization and making some kind of the devices for quantum sensing. Well, I think I should stop here, but together with Rupamanjari, we wrote a very nice article that came out in Physics World, and that is the link for that. If you really want to know, and read it, here is the link. I want to acknowledge a few people. Shubha Das Malik, who was the science communicator of S.N.Bose Center, she really helped me in getting some of this information that I shared with you. Dr. Manik Bonik, in fact, few of the slides I showed, initial design were done by Manik. The Purnima Sinha and her doctoral work under Professor S.N.Bose, there is this very nice article by Rajendra Singh and Shuprakash Rai, which was published in Science and Culture in 2019. And I could only give a glimpse. This article actually is a very nice one. If you really want to know details of her thesis, you should read this. Together with Manik, I wrote an article on Vigyan Dhara, and together with Saqib Samim, also from my institute, we had an article in Science India. And Shubha Dashmalik also made a very nice movie. Those who are interested in history of science may like to watch this. It's called Dear Master. And here is the link of this movie for anyone who will be interested. Finally, thank you very much for your attention. And I'm very happy that I could at least give you some kind of glimpse of this very, very complex title that Shikha has given to me. Thank you very much.
Thank you, Tanushri, for very nice. We nicely addressed all the things that you were promising. So thank you very much. And since both Sukanya, Suparna, and also Sudeshna are here, so we would also like to hear some of their memories or antidote, what they can tell us about Purnima Sinha and her connection with the S.N.Bose. Yeah, please, in whichever order you want to go, please.
Okay, let me just say a few words. Thank you, Tanushri, for an excellent talk. And I was also at the conference, which was very well organized, and it really gave a remarkable glimpse of how many young women are working on doing excellent work on quantum physics at this point. It was very impressive. So since this question of, since you brought up Chandrama's story, there was another anecdote which I mentioned in the talk there, is again about clothing, how things, how progressive he was, because once My mother had gone to his house. They were very, like though it was a advisor-student relationship, but they were very close. So she used to visit him regularly at home. So she went there, and his daughter said, Purnima, why aren't you wearing bangles? This is not okay for a woman. You should be wearing bangles on your. So he intervened, and he said, like, why should she wear bangles? She makes big machines, like she doesn't have to wear bangles. So that was one anecdote. The other one was regarding this. So clearly we know that even now, the main block comes from hiring as faculty or getting a job beyond the PhD. So apparently, so as you mentioned, her work was in studying the X-ray crystallography of Indian clays. And when she was doing her PhD, her scholarship was from the Assam Oil Company. So it was sponsored by them, and she had this huge amount of scholarship, like because it was an industrial scholarship, she was getting 350 rupees, whereas the government scholarship was 75 rupees. So, and clearly they had some interest in knowing the structure of clay for drilling and all of that. So post her PhD, they had asked S.N.Bose for recommendation for a scientist for a permanent job with Assam Oil who had expertise in structure of clay. So he asked her to go. He recommended her, and she went for the interview. And they were kind of shocked. They said, like, this is the kind of work you go out in the field, go out in drilling oil fields and all that. Why did he send a woman? So she said, like, I don't know about that. He sent the person who he believed was the best expert, who knew fit your requirements. So she didn't get the job, but it was very interesting that he found it fit to recommend her name for. He had the confidence, and so as you said, like he was way beyond his times in the regarding the gender issue.
Maybe I'll talk now. Yeah, my talk will be somewhat different in the sense that I'll just talk about some overlap and interactions with my mother in the domains that she was interested in. So in some ways, she was a non-standard scientist. So although she had, her core was that of a scientist, but she was equally talented in art and also music. And thanks to her, I got exposures in those areas. Maybe first I'll just start with science part. Okay, one of the things that she used to say always that of the things that she has done in her life, building the X-ray machine has been the most dear to her. Like even more than analyzing the clay samples and figuring out the structures, building the instrument was the most satisfying. And one more interaction that I had with her in the context of science was when we were at HRI for about a year. And it so happened that I was doing some work in the theoretical domain of statistical mechanics of biopolymers and like DNA. And I started chatting with her about my work, and she asked, she got quite interested, and she asked several interesting questions. One of them had to do with the fact that she said that, okay, all this is being done at the molecular level. How does this microscopic level connect to a macroscopic structure where you have a whole biological entity like a creature? How does that gap get, how does one bridge the gap? That was one of the questions that she asked. And it so happened I went to the library and I found a very interesting book, popular level book, I would say that's a technical popular level book called Unraveling DNA by Kamenetsky. And I had just left it behind. And when I came back, I saw that she had started translating the book into Bengali, and which was an enormous task from any point of view, because that means that she had to pick up like state of the art ideas as well as terms in molecular biology, biophysics, and that to translate it into Bengali, which was an enormous task, coupled with the fact that her eyesight was poor at that time with a macular degeneration and all. So that was one thing. And in terms of collaboration with her in science, I collaborated with her on a article which was published in Gyano Vigyan later. That was a Bengali translation of an article that my theoretical physicist husband Joseph Samuel had written. It was called Torches, Clocks, and the Lorentz Transformation. And my mother and I sat down together and translated it into Bengali, and it was published in Gyano Vigyan. So now I'll just briefly tell you about my other interactions, because she was actually an outstanding artist and also a musician. Art was, I think, perhaps more dominant than music. She had learned art from this very famous landscape painter, Gopal Ghosh, when she was in the school years. And in later years also, she had connection with Gopal Ghosh, and I got to see Gopal Ghosh actually drawing and painting and so on. And that also stimulated me to do art alongside. And with her, I illustrated and made the cover design of a couple of books written by my father. That was the art part. And the music part was another thing that was unusual. She learned to play the tabla. Imagine in that era, for a woman to choose to play the tabla. So she learned it from Gyan Prakash Ghosh, outstanding tabla exponent. And this time also I was very lucky. When I was about 8 or 9, she took me to Gyan Prakash Ghosh's class. And then I got to learn tabla for about a year from him. Of course, I didn't reach anything like the level that my mother reached, but that was also something that I was very grateful. So I think all in all, apart from everything else, she had provided an outstanding home atmosphere where creativity could flourish. And I think for that also she needs to give credit. Thanks.
Yeah, it's wonderful to hear both of you to give us some glimpses into her real life also. I don't know if Sudeshna wants to say something. Otherwise, it's also open for question sessions, whatever. If somebody has
Yeah,
questions.
actually, I can't add anything more to what they have said. I just wanted to say just one small thing. Purnima Sinha, Jethima to me. I realize this now more than I did when I was young, unfortunately, is that she was really out of the box and with no sense of boundaries in a good way. And though this may be an intrinsic thing, of course it was, but there was something, I'm sure, which Bose's, this atmosphere that he, encouraged and as a very worthwhile thing, it must have also played some role. And, I think we compartmentalize, as I think Tanushri was also saying, people a lot more nowadays. Focus is the thing. I think this having less barriers was one of those legacies which I think as I grow older I see is rarer and has to be treasured and understood. So Jethima had that in ample measure, and just watching her was wonderful. Yeah. Okay, that's it. Yeah. Okay.
Thank you.
Definitely.
Yeah, great. Mhm. Yeah, so these are really things which tell us about yeah, the person. And of course, science we hear part the little daily things. Yeah, it's very nice to know. Now the session is also open for question answer. If there are any questions by on YouTube or on Zoom, we are also uh, doing live streaming on Zoom on YouTube. So, in case there are any questions. Okay, so while we are waiting, I'd just like to know. So, S.N. Bose had this very kind of, I'll say, uh, he was so appreciative of the gender roles. How did it come about? Did it come about before he went to outside the country, or like while he was in Dhaka or in India, he still had those values and ideas?
I feel he was just his own person. He was
I
just
think it's
so different.
yeah.
He was, he was not. I mean, he's not a guy. I mean, he just thought his own thoughts logically, and it made no difference to him. As Shukona was saying, the best
Yeah.
person for the job. Like, that's the logic part,
Yeah,
right?
yeah. It's like it
Yeah.
sounds really amazing about
Yeah,
that
it
for
he
the
had no
job or
baggage. He didn't carry baggage, basically. Others carry a
Mhm.
lot of that.
Yeah,
At least that's what
uh,
my grandfather, who was his personal friend too, in
yeah,
Paris and otherwise, he was a
Right, right.
historian. They were very good friends, actually. So he would
true.
always say that he was such a open and he just went with the where the thought led him, not with anything to hold him back.
Yeah, I think just like a very, very outstanding person in this matter. I mean,
Yeah.
like there were some people who were just like that. Like my maternal grandfather was also like that. I mean, the reason why Purnima Sinha flourished, if you
That's
trace it
also
back,
true.
that
Yeah.
is because of
That,
nourishing,
yeah,
providing
yeah,
an outstanding
that's very
yeah.
important.
atmosphere for women to flourish, and all
Yeah.
the all her elder sisters, three of her elder sisters,
Yeah.
one of them was the first woman to receive a master's degree in economics from Calcutta University. The next one was got a bachelor's degree in mathematics. She was deeply interested in math education. Another one was a chemist who was also first postgraduate in chemistry from Calcutta University with a master's thesis. So all these people were older than my mother. The youngest
Okay.
of the lot in that was 14 years older than my mother. The elder one was 24, yeah, years older. So I think these are singular people. You
Yeah,
cannot compare
yeah.
The
them with
other
others.
thing I wanted to just mention, what I've heard from my mother, that this is not only the gender barrier, as Sudesh also said, like he was just a person like that, but very exceptional, and I think he developed it completely on his own. It was also cutting across the class barrier, and I think that was very important, because what my mother told me, that when he was working shoulder to shoulder with the workmen in the workshop building these instruments, he used to sit around like with his arm around their shoulder, which was unheard of at that point, like with caste barriers, class barriers. He managed to transcend all that, which was very remarkable as well. And I think that atmosphere sort of permeated the lab and the culture in general. Yeah.
Another thing to contrast with, say, people like Anna Mani's reaction to C.V. Raman, they were quite scared of him. But there was no sense of fear in my mother. Like S.N. Bose was one of her closest friends. She was not afraid of him at all. And that egalitarian atmosphere was very remarkable in Bose's lab.
So I don't see any raised hands, but I don't know. Somebody has a question.
Or maybe Rupa, would you like to make any comment?
It's been a wonderful session. And
As a co-author of her article.
no, I think you covered it well. The first part really went off well. Of course, the full list is available and it's a longer list. I think in my mind, all that we are talking about, the biases, the shadows that we often do not even acknowledge, for example, biases in mentorship, assumptions about potential or gatekeeping in opportunity. These accumulate over time to limit visibility and opportunity. We see that, and my only one word understanding of that is it's a reflection of insecurities that you did not see in Bose or of that generation and the next generation in Calcutta. Many of us, Tanushri inclusive, my own family, if you look at your parents and your grandparents, the kind of atmosphere you got in Calcutta, there are no insecurities. There is a clear division of labor probably in some ways, sometimes not. But then there are no insecurities on men. So you actually could be fair and could be natural. I think Tanushri has been saying this for years now, that Bose was a natural. He didn't think about this issue. It was not an issue for him. So gender was a non-issue because everybody came as they came, and because there are no insecurities to see, look into your eyes and realize what. So I think we have a long way to go. Something that we have lost on the way, maybe. Now IPA is doing a great job, and Shubhavati and Shikha, all of you, to be really congratulated for that. But we have a long way to go. We are nowhere close to what it should be. But first thing in our mind is to check whether I'm insecure about my students, am I insecure about my colleagues, to try to block them, or actually should we just aid each other in making out the best in everyone? We are all different. We don't have to be the same. And if you are all the same, then that's the end of research anyway. That the progress of knowledge is halted when everybody thinks the same way. So some conflict is necessary. Difference in opinion, difference in views are necessary for knowledge to propagate. So I think all of us should come out of it and understand that in this collaboration, what Tanushri also showed, number of examples in the collaboration is everybody's, progress, and that would bring wealth to the country and to the community across the border. So thank you very much for this session today. These inspirational stories of Purnima Sinha and everybody of that, very few that we have, I think should be told again and again, so that people know that this is all very natural and there is nothing, maybe the barriers we are creating are so artificial, and that should be ridiculed at points. So we are not trying to hide mediocrity, but acknowledge what everyone is capable of and what contribution everyone can make. A nation cannot aspire to be, shining in the knowledge economy, as they call it today, if 50% of its population is not allowed the potential to shine, to come up to its full potential. So I think that's something that all of us should remember and prepare.
In this context, I would just like to say, you said exactly what Bose used to say. He had actually told my mother, if 50% of the population is left unused, then it's a big loss. Talking about women,
Yes, I have a old photo when I was 4-year-old garlanding S.N.Bose that I showed in my talk.
Oh, yeah.
Remember? So
Yes,
I didn't know. I didn't know that I'll come to physics at that time, but we were from the same neighborhood in Calcutta. One thing I shared with him that I learned later, he used to play the esraj, and I still have an esraj in my house, and it belonged to my great-grandfather. So music seems to be one thing physicists have in common, and I think you talked about it, about Purnima Sinha, tabla and other stuff. So it's been great. I think we should have more sessions like that, but more importantly, it's not like we are asking for any advantage. We're just asking for what would be a support to excellence in physics, in this case, or excellence in science by fairness. So fairness allows excellence to shine in, and that's something that I got the message again from Tanushri's talk and all your recounts. Thank you so much for inviting me to be here.
Give this talk at a very short notice, and lots of iterations were also going on, and she has really put us very nicely in this elaborated on Purnima Sinha with S.N.Bose and quantum women. So very well apt talk, and thank you very much for Tanushri for
Very much
agreeing so
also
readily.
thank you, because it was also a learning session for me, because I got to know many things from really the people who are close associate. So many of these anecdotes, these are just not anecdotes. This tell us much more beyond just the anecdotes. It tells about a person, personality, that era, which Rupa Manjari was trying to say that somehow we have gone down, but if we keep on give ourselves reminded about that era, maybe we'll be able to push back again. So it
Yes.
was, thank you very much. For me also, it was a great experience. Thank you.
Yeah. So thank you everybody for bringing in your thoughts to this program, and together we will do something else. Okay. Thank you.
Thank you.